Okay, hopefully I'm actually live this time. Let's see. It says it's upcoming. Upcoming. Waiting for me. Now it's working. Okay, I don't know what that was all about. Okay, I guess there's just a lag. All right, so sometimes I find this very, very confusing. Okay. Anyway, hopefully I'll get the hang of this before too long. What do you see on the screen here? This is what I made last night. Hang on a second, it still says upcoming. All right, it says I'm live. I believe it now. All right, so this this up here is what I made last night in my previous stream. I was trying to demonstrate Mondrian, and I realized the mistake I made is, sometimes these videos are just a watch me code kind of thing, and this is one of those. And yesterday was one of those, and I thought it was going to be a more of a presentation of something, but really it's more of a learn how to do something and just deal with whatever comes up. And that's probably going to be the same tonight. So I'm using this tool called Mondrian, which is a graph drawing library for Pharo Smalltalk. This is what you're seeing here is an environment, a shell called Glamorous Toolkit. And it's called a moldable development environment, and you'll get to see a little bit of that. But basically, the idea is you've got this notebook, and you've got this is Smalltalk code, and then when you run it, it actually produces this result. So this is the result of the Smalltalk code. It's an object called a Bex canvas that has different representations, and one of the representations is this drawing view, right? So then you can click on, I also clicked on that, and then I can see the code for the drawing. So basically I said, it's a Mondrian view. So Mondrian is the name of this drawing library, and it's called drawing, and this is how you paint it. And then basically basically this object is called a Bex canvas. And it's got instance slots, so it's got a bunch of. That's actually interesting. That's not what I expected to see. I should be seeing NIDs, right? I should see something called NIDs here. Interesting. I'm a little confused by that. I don't know why that would be I wouldn't show that. Because when I initialize it, it says NIDs in BG color. And it's meant to show, this looks like a bug here. Oh, NIDs and BG, maybe I didn't, I was just looking at the wrong slot. Yep, okay, sorry. I was looking in the class ones rather than the instance ones. Although the instance slot should contain NIDs and BG color. Except I'm looking at the class, right? So I'm inspecting a class. Interesting. And so the class has instances. It has its own slots. That's interesting. But if I instead inspected this is a Bex canvas class. Now it's a Bex canvas. And then if I say meta, now I see the. Oh, okay, I see it. It just doesn't even show that. Check the object. Okay, I'm getting used to this. So anyway, what you're seeing here is the moldable development environment. The idea is that like pretty much anything you can click on gives you some kind of inspector, and then you can create new kinds of inspectors yourself. And it's very easy to create inspectors. Not quite so easy to get your mind around what it is you're clicking on, and it takes a while to learn. There's a learning curve to it. And And so I'm trying to be a little more cognizant of what it is I'm clicking on and looking at. Anyway, the goal for tonight is to take this canvas and fill it with interesting things. Okay, so you can't just do that because of that semicolon. But if I say Control G, then okay, now I've added the O constant, the 0. So this is false. And then if I do this and Control G on that, then I get the whole thing, which is the same as just running this inspector. So basically, I've made an example canvas here. So the constant example is a canvas that contains these two things. And what I'd like to do is now extend this idea. This is about as far as I got yesterday. I created BexO and BexI. These are separate classes that represent those kinds of nodes. And then they have a superclass called BexConst. I think if I just click on BexConst, and so that defines border and the color and the geometry and all that stuff. And so now what I want to do is I want to make something a little more akin to these diagrams. So let me just give you the pitch of like what it is that I'm trying to do. So I have this software called Bex for Boolean Expressions. It's written in Rust, and I'm looking to talk about what it does in future videos, in scripted videos. I want to be able to make presentations about what this thing does. And so one of the things it does is it lets you represent a function like this, or this isn't a function. This would be just a Boolean expression. Sometimes I call it binary expression because the word Boolean is odd to say and it's somebody's name, and it's named after George Boole, right? But it could have been anybody, some other genius could have discovered these expressions. So I think binary expression is kind of a more, I don't know, just a different way to say it. Not to rob the guy of his legacy, but I think it's clearer to say things in terms of what they are rather than who invented them or who discovered them. Especially given how prone to error the naming system is. Anyway, so in this case we have variables a, b, and c, and we are XORing them together. XOR is this, maybe I make this bigger. XORing is the same as the not equal. Literally means one and not the other, so not both and not neither. So that there's two of them and they're not the same. So not equals is the symbol, or is a symbol that some people use for XOR. And then this is the symbol that some people use for AND. So XOR and so this is the diagram of that expression. I said it was a function earlier, and then I said, well, it's not really. So what would make it a function is if you took this and wrapped it in some syntax for functions, and then said a, b, and c were variable names. There were arguments to that function. Otherwise, it's just it's what we call an expression. So in Bex, Bex is not really a language, but it has a little shell that has this what's called reverse Polish notation, and you can write it like this. So you say x0, x2, and that pushes these things onto the stack. So actually, we're pushing three things onto the stack. So x0, x2, x1. These are input variables. We use there could be so many of them that we're not going to give them names, right? They just have these names: x0, x2, x1. And then we say XOR, and so that takes the last two items off the stack and it XORs them together. And so that what it does is it creates a node in a database. So we're building it what I call an abstract syntax tree, but it's basically just a list of definitions. So at the start, everything is empty. The list is empty, and then these are kind of like constants, so they don't need a definition. They just represent themselves. And when I get to this, then basically it takes these two things off the stack and it creates a new definition in the list of definitions. And so that definition is going to look like it's got two fields. The field is op. It's saying, what does it do? So in this case, it would be XOR. And then what are the arguments to it? And in this case, it's X1 and X2. Might make sense to me for them to be X2 and X1 because the order does matter in some cases. But for either XOR and they don't. So I might need to rethink that. I might need to rethink the way the shell works because it's probably just popping this one off, making it the first argument, and then this one off, making it the first argument. But if this was like the less than or implies where the order matters, then you would probably want to pop them off in the opposite order. So this is probably a mistake now that I think about it. And likewise, and would probably, like I think over here, the variable came on this side, and over here because it's coming out on this side because just of the order they're being defined in. But in any case, so these two get XORed together, and that makes a result, and then the X0 and the result are ANDed together, and then you can type the word SHO to show, and it actually generates this this text. It actually generates this text in a language called dot from a package called GraphViz, and then GraphViz turns it into an SVG, as does this observable notebook. So I just pasted the string into the notebook here. Okay, so this like visualization feature comes with my software right now, so Bex can already do this. But then I wanted to. There's like when I want to explain what does Bex do with that information, and we get to this, and the idea here is that we're taking this diagram, and we're going to say, okay, I'm going to perform the if then else decomposition. This is also called Shannon decomposition after Claude Shannon, and again, I prefer to just give it a descriptive name rather than a named after somebody name. And so the idea here is what you're going to do is you're going to pick one of these variables like X0, and you're going to say, okay, well, when X0 can either be true or false. So when it's false, show me what it is when it's false, and show me what it is when it's true. And so here we have X0 at the top. And see, like here, first X0 was something that was like being input into the flow. The data is flowing upwards. And now we have this thing that, you see there's no arrow coming out of it. It's just up at the top, and it's got a dashed line and a solid line. So this is indicating that depending on what X0 is, we're either going to evaluate this or we're going to evaluate that. Maybe this is not a very good notation, but like I'm blending two notations. This is like the notation for what's called a binary decision diagram. And then these are what I'm calling the abstract syntax tree. And so you're blending two different representations here. But you can also see that basically we've made a copy of this structure. If I shrink it down a little bit, you can see that we've made a maybe you can hide the bookmarks bar. What? Never show. Okay. So you can see that it's taken this X0 and replaced it with a false and a true. And otherwise, it's exactly the same. So we've made two copies of it, but they're slightly altered. So that's how if then else decomposition works. And I made this graph. Bex does not exactly do this algorithm, right? So that's part of the problem. It's like this is the slow, naive way to do what Bex does and arrive at the result that Bex will eventually arrive at. But the problem with this is that you're going to double the size of your graph here, basically for every input, because you have to make a copy of it, and then you rewrite one copy and rewrite the other copy and you simplify, and it gets complicated. Anyway, so then we do it for the same thing for variable x1. So we take two copies of this. So again, let's shrink it down, and then just so you can see the structure, like this whole structure is mirrored here and here, only we've changed these. We filled in these. Well, for everything on this side, the x1, there was 2 copies of x1, so they both got replaced with false. And then over here, they both got replaced with true. And so you can see there's this pattern of, this one goes 0, 1, 0, 1, and this one goes 0, 0, 1, 1. And then the next one, if I were to do that, would have 4 zeros, 4 ones, 4 zeros, 4 ones. And then the next one would have 8 zeros, and so on. It keeps doubling in size. And yeah, so the problem is to make these graphics was a ton of manual post-processing for me, because I basically started with this and kind of manually made the graph. Or I think in this case, I got Bex to make a graph that looked a little bit like that, and then just changed the variable names in the XML or in the GraphViz source. But yeah, right now, Bex itself is not meant to be a visualization engine or a tool for working with these things, and I don't want to make it that, right? Because it's not really the right tool for the job, right? I would much rather use a nice dynamic language like Smalltalk or Python or JavaScript or something like that, where to do this kind of thing kind of on the fly, to make the graphics on the fly and be able to debug them rather than going through a compile cycle and so on to make a graphic show up the way I want. Especially if it's recompile the interpreter, type something in the Bex, recompile Bex and the Bex shell, then fire up a new Bex shell and type something in. You don't want to be doing that. So I'd much rather just make a new thing that visualizes this stuff, because this is not the important stuff that Bex does. This is really just the input to Bex, right? These graphs can be made very, very quickly in any language. They don't take a lot of processing power to make. I guess if you keep doubling them, then they would. But if you keep doubling them, they're not something you're going to want to look at anyway. After you get to 2 to the n, 2 to the 16, you have 65,000 copies of something. It doesn't do anybody any good. But to illustrate the algorithm, I really want nice, not just diagrams, but animations. And so I'm not going to build that all into Bex. So what I'd like to do is have something that can talk to Bex and at any given time, request the current state and visualize it. And so my thought was, let's make a web server for Bex that can inspect what's going on and let Bex dump out JSON or some kind of custom notation, and then visualize that, and then maybe even be able to send messages to it, and make a shell that works by but through the use of manipulating these diagrams. So yeah, and then also I'd like to be able to give this presentation through that shell, either interactively, record my screen doing that, or make a video and just record, actually create an animation, save it to disk as a video file, and then splice that into my video with a voiceover. So that's kind of where I'm going with this. And then I guess just to finish the story of what Bex actually does is it keeps doing that, and then it simplifies things. So every time you see true XOR something, well, that's just true XOR X2 is just not X2. It's X2 with a not sign in front of it. And then actually that's false. Sorry. So false XOR something is just the thing, and then true XOR something is not the thing, right? Is the opposite of the thing. But if you keep simplifying that, then you eventually will return this, or rather this, into this, which is what we would call the truth table. So it's a fully expanded binary tree, and the order is always x2, x1, x0 on any path you go down. And then also the low branch is on the left. So when x2 is 0, it's over here. When x1 is 0, it's over here. x0 is over here. So this is when they're all 0, and this is when they're all 1 or high, low and high, 0 and 1, false and true, whatever you want to call it. And then, so this gives you the truth table. So for 3 input variables, x2, x1, x0, you get 2 to the 3 entries in the truth table, which is 8 entries in the truth table. And so this is a fully expanded binary tree or binary decision diagram. And then what Bex does is it actually makes something even cleaner. Is it compresses this by saying anytime you have 2 copies of a node, like first of all, if you have 2 things that are like here where you're saying if, basically it says if x0 then false, else false. So the branches go to the same place. So you can just eliminate that node and just go from x1 directly to false. And so you have x1. So basically, if not x1, go to false, right? And likewise, on this side, if x1 is true, then you go to false. So here's x1 being true, and it goes to false. And in the middle here, you see x0 and x0. These are the same nodes. So this subgraph is exactly the same as this subgraph, and so you unify them. And so you see that x0 is you just have that one branch from low is false and high is true. And I think that's all that happens there. Yeah, so I think that illustrates all the simplification rules. And so anyway, this is the thing or this is one of the things that Bex produces. It's called a BDD, or it's actually a reduced ordered binary decision diagram. But this is like the most common kind of binary decision diagram. So instead of ROBDD, we just say BDD. So this is what what my system makes. It's basically a graph that is a compressed truth table. And kind of the problem with it is that it, in order to get to this point, you have to go through some stages that might be, it might deal with some exponential blowup. But that's kind of like the story that I want to tell in future videos. So I've talked through it here, but I would like to make this presentation much smoother and more graphical and animated and whatnot. And so that's what kind of I'm looking at here, is to be able to do those kinds of visualizations on the fly and make them interactive, and maybe even say, well, like maybe even starting with something like this, say, well, what happens if you fill in x1? Like, so now you've got x2 and you've got x0, but you don't have this x1 layer. And what happens if you set it to false, and what happens if you set it to true? Show me what that's like. And so that's kind of what I want to get to. And so I want these interactive diagrams and graphs. I think that's it. That's all I have to say about that. So let's get started here. Okay, so I don't need this anymore. And if I just run this, we should get back the diagram. And so now let's talk about input variables. So these are constants, right? These are actually constants. Drawing constants for Bex. All right. And yeah, we're going to make some variables here. So if we go back to we expand this, we'll get the notebook in which this is created. I'm not entirely sure why these are under this that doesn't make a lot of sense. But okay. Let's make a new page, and we're going to call it drawing variables. And then I believe you don't have to do this, but if you want the notebook to look like something, then you can say, okay, drawing variables for Bex. And then I guess maybe I need to make an actual page for this too. So let's make a page for let's call it Bex visualizations, Bex drawing system, or just we'll call it drawing binary expressions. And then we'll make one called Pharo stuff. All right, and so then back in here, we'll replace this with Pharo stuff. Pharo is the name of the programming language that is behind this thing. And we'll call this drawing binary expressions. All right, so, all right. And then just to make sure, so then all of this actually gets saved to my Git repository. You have to wait for this to sync, and then, so let's just commit. Say add some pages, add pages for drawing binary expressions. Drawing, clean up pages. All right, and then that you can push it right up to GitHub, right, if you want. It says github.com /TS Pharo, -Pharo. Okay, so, all right, now we've done that. Now we can click on drawing variables for Bex, and there we go. Now, I think actually if you click on it over here, then it replaced, see it replaced, this is the one I was looking at. It just removed the table of contents. It hid this part, and then it opened a new page. But if I just want this page to open, then I should, rather than clicking in here, I should click here. So drawing variables for Bex. Okay, and then we can close it down. Okay. Okay, so let's say, well, let's just draw this expression, right? So I guess I want to say something like, Bex def, so Bex node def maybe? I'm just gonna call it def. First of all, this needs to be a Pharo snippet, not a, so you say new snippet type equals Pharo. Now you got Pharo code in there. And we'll say Bex def, and that's gonna be a class. We're gonna create class Bex def, and then it's going to be in package Bex, and I don't know what I'm going to do with it yet, so I'm just going to say go. So now it's made that class, and then later we'll check that in. So now if we come over here, we see it's created the class for us, and then I've modified that page a little bit. But since there's no code here yet, I won't. I'm not ready to check it in. You know, the Smalltalk has, like, keeps everything in its own little memory database. So your editor is the live system. So, but there's the tools allow you to sync with a Git repository or any kind of external repository. I guess this one is a Git client, I guess. All right, so we're going to say Bex def new. Well, what do I want to do? I think we'll probably just say Bex def, like, you know, make a factory method. So Bex def, first we'll do and oh, let's say and what are the arguments of this? So let's just say, okay, so we're gonna fake this a little bit. We're gonna pass in a list of arguments. I'm not sure if that's like the right small talky way to do things, but then we're gonna say Bex I wonder if I should just make an object called Bex that's like the builder, right? Because like, yeah, so like Bex x0, or I could say x0 something like that with a, yeah, then because these could go up really, really high, right? So Bex x0, and then Bex and would this be a def? Let's call this Bex. I do want a Bex def class, but so okay, so we're gonna do it like this. Now say Bex x0. I bet we can say this x. No, because you wouldn't collect them that way. A list. You can send multiple messages to the same object. So in this case x, but you can't. You wouldn't collect them. You would only get the last one. So you really want Bex x1. So Bex would be is a factory kind of thing. So all right, so this is going to be a class, create class Bex, and it is a object in package Bex. All right, and it needs to have a method called and in Bex class, and a list. And then is assert? No. How do you do an assertion? Let's see. The tests have assertions, but let's see, Pharo assertion. Yeah, I don't think there's not a lot of I don't think Pharo has like online docs, does it? Because it's all you're meant to use one in the system. So pharo.org. Yeah, it does have documentation. Okay, Pharo wiki, Pharo. Okay, not what I'm looking for. Okay, let's search for assert in here. Assertion failure. Object assert. Oh, because I said assert, but I didn't say self-assert. Okay. A list. Let's call it args. how about arg list? Arg list size equals 2. All right, so we'll self-assert and then is there like a and then let's say description and takes a list of 2 arguments. Okay, and then now we want to return so a bex def new op is so B001 0001. That's not it. It's 2 radix 001. In J, you can say, well, you know, in Rust or maybe even in Rust, you can say that if you want a binary, a bit string. In Python, I think is the same thing. And then in J, it's 2B, and in whatever this is, Smalltalk, it's 2R. So the radix, 2 radix 00, and then J was 2 base something. All right, so op. So this is the truth table for and. I think even just this would probably make sense. Op and args is arg list. And then arg is arg. I think I like that. All right, so we're going to add this. Create method op args in BexDef class. Done. And we're going to say op is equal to an op. And so how about a bit in Rust I would call this a U32. A U32. Op is a number, an integer. A uint, an int. And op is an int. And then args and arg list. So we say actually def is equal to self new, right? So this is actually a local variable. And we're going to say def is equal to def new, self new. And then this is a slot on the so we need like a setter. We'll probably do def op and args. So we'll say an int because there's no way to just set the internal variable without passing it a message. So you have to do it like this. How about we say super new? All right. Okay. So you just okay self new op. Yeah. So there has to be a corresponding message on. Okay. I'm not used to thinking this way. And then we're going to return. So we don't even need this now. We don't. It doesn't even name. All right. So we're just basically saving the word new here. All right. So now we can say add this. Yes. All right. So there's a class method named op_args and an instance method named op_args. And then now we just say op equals and int args equals arg. I mean, this might be overly complicating things. All right. Anyway, now we want to add an instance slot. Add slot in backstuff. Okay. I think we say yourself, right? So yeah, so it needs to be like a cascade. Yourself. Well, let's see. What if we do this? That inspected to something. When I inspected it, produced something. When I do this, I hit Control P, it returns nothing. Oh, partially because we don't know what these values are. Right, but if I just said, if I were to just say like, so if I said Bex_def, and then op_args, then whatever. I print this, I get a Bex_def. If I said Bex_def new op_args and I print it, I still get a Bex_def. Why is that the case? Does it just, how does it know to return? Because if I said like return 7 here, and now I do this, it should give me 7. Yeah, it gives me a 7 back. But if I return nothing, does it just automatically return itself? That returned a small int. Hang on. I wanted to delete that. I guess maybe there's an implicit return self at the end. Okay, I guess that's fine. Okay, so this could actually be a definition of false, right? Because it's always 0 and there are no arguments to it. and I guess true would be this. But they're going to be separate classes. So this is meant to be for things that are higher. So okay, so this we don't need this. So Bexdef op. All right. Oh wait, hang on. This is a Bexdef class. I don't want that. I lost the thing here. So this should be self new op and integer args list. And this should be onions. All right, so now when I run this, yeah, now I get a Bexdef and not the class. That's what I want. All right, so I had the same interface on both this, but it's just to save the word new. Right? That's all I'm doing is saving the word new. Okay. Now I wonder if I should just make this Bex. So what does Bex look like? Bex has this and method. What if I just, let me unify these two things. Oh, and I created it, but I didn't do anything with it. So let's actually delete this. Bex is not referenced. Let's delete it. And so now it's a package. But let's look at Bexdef, and we're going to rename this to Bex. No, we don't want to remove it. Open it up. Class object. Oh, okay, you just double click here. Okay. You just rename it that way. Yep. All right, so we're going to call that a Bex. So then we're going to say Bex op. So Bex op now, when we inspect this, it should work. So a Bex, yeah, that's fine. It's a Boolean a binary expression. I represent a binary or Boolean expression. Okay. What does this say? Okay. All right. All right, so X is a class, it has that comment, methods, definitions. Okay. I'm thinking like in the Rust package, you wouldn't just have, you know, there is no such thing called a Bex, right? And there you have NIDs, and they represent nodes in a particular structure, and then there can be multiple structures because there's different kinds. But I think in in this system, I'm only going to have only one kind of AST, only one kind of well, see, I can also have like direct pointers to these things. I kind of like the idea of mirroring what's in Rust because I want to visualize what's in Rust, and I'm going to be able to pull in from what's in Rust, and so I should mirror. Yeah, that makes sense. Because it's not just to visualize binary expressions; it's to visualize binary expressions in Bex. So it's both for explanations about binary expressions in general, but also visualize this software so I can debug it or whatever. All right. So anyway, and it is going to be a message here. Oh, I deleted it, but I didn't copy that method. I didn't copy the method. I meant to copy that method. Okay, that's fine. All right. So if we add a method here, it should appear over here. And arg list. So I forgot to say self assert arg list size is equal to 2. Description. And takes 2 arguments. And then, so then we're going to return Bex op OR001 and args arg list. Oh, integer, yeah, right, sorry. 2 is the number here. Okay. Okay. So Bex and then maybe the constructor could, maybe it does make sense to make this a Bex def or whatever, but and split the I'll have like just the class as like a constructor for these things, and then def would be the actual object. So that probably makes more sense because here we want to say an integer. Return Bexvar new vid x. All right, so Bexvar is a class. It's in package Bex. Yep, good. Okay. Actually, we can change that, and we'll actually add a slot called what's the slot going to be called? The vid. All right. And then the vid is vid actually it's really a nat, right? A natural number. Vid is equal to a nat. And then we don't call that x, we call it a nat. Construct a variable such as x. Okay. All right, so let's just do it like this. We'll make it like a tree. And then x and this can all go in there. So I think that actually does make a tree. Right, so we have self args. It's a bex. It has an op called okay. What I was going to say is that, like, we're not the op itself here. It doesn't know how many arguments it has. So you know, there's a binary expression. There's an operator that takes 2 arguments, and it returns true when they're all true, and that's called and. And then there's, you know, a similar one that takes 3 arguments and 4 arguments and 5 arguments, and those would all be called like all 3, all 4, all 5, all 6, all 7, all 8, and so on. But they would all have, if you don't have a way of saying what the arity is, you know, the number of arguments, they would all have the same truth table. And in fact, if we I mean, we do have the fact that the array has 2 items, and that's fine. Maybe that's okay. But like I also said, op1 is also a you know, you could treat that as just like the constant true. Or you could say, you know, if it only takes 1 argument, then that would just be the variable. Whereas, you know, because if the truth table goes 0, 1, that's just the same as, you know, given the variable, choose either 0 if it's low or 1 if it's true. So it's the same as the variable. And then if you had 1, 0, then it would be the inverse, right? It would be like not x. So you really, the op really needs to be something more than an integer, is what I'm getting at. All right, so maybe we say, maybe and becomes op. Maybe just pass in like and for now. Just a symbol. All right, so now if we run it, it says and. I like that better. It means I have to do something with it, something different with it later, but that's fine. Okay, so now what am I looking at here? And 1 is 97. These are the symbols. These are the characters. That's weird. All right, so now when we ran this, we got something that's an and it has 2 arguments, I hope. 2 items, yes, okay. And the first one is a bex_var, which should be x0. It is 0. And then we have a bex, so a Boolean expression, binary expression. And it has 2 arguments, and it's also an and because of this. And then 1 and 2, and those are both variables, and they're x0 and x1. But that is actually not what I was trying to draw, is it? What I was trying to draw was this. What I was meant to draw was this. So it should be x1, x2, xor. And so this should be xor, which does not exist yet. So let's create that. Arg list, and we'll say so bex def bex, what was it, bex hop xor arg arg list. And then maybe even so assert arg list size equals 2. XOR takes 2 arguments. Exactly 2. That's a comment. Takes exactly 2 arguments. Here we go. And then we return this. Okay, so close that. And you can see how ugly these little object trees are. Same thing if you wrote it. Oh, I don't know if you can even see that, but my head's in the way. Really, one of these days, I'm going to make a thing that I can drag around here and see what, that covers my screen, so I don't see the, I see an obstruction where you see things. All right. So anyway, we're going to AND x0 with, and this should be x1 and x2. Okay. All right. So now we want to draw this. So let. So we're going to say okay, so we'll call this just AST is equal to this. This is the abstract syntax tree for abstract syntax tree. Or actually, we'll call it what the expression is. So just AST for x0 and actually, can I copy that little symbol? Okay. For x0 and x1 is not x2. x1 XOR x2. Okay. All right, so we can add a toString class here. So how about as string? Yeah. And we can return Let's see. Arg list is args. Args size equals 2. Arg size equals 2 if true. Then we'll do and as, let's see, how about as dyadic? As, or what do you call it, infix op, as infix string. And we'll say that. No, I think we have to say self, right? Self as infix string. If false, then so let's say S. Is that going to tell me it's not used? Is that what's going on here? Temporary variable is not used yet. So S is going to be equal to op as string, comma, and then we're going to return S comma that with a close bracket. Yeah, so that, and then how about op as string? Do I need to parenthesize? I'm not sure. And then args at 1 as string. S equals S comma S comma args at 1 at string, and same thing args at 2 at string, and then return S comma. Put a space there. Oh no, you can't do that. So you'd have to say you want to say you want to say I'm going to say args each args for each message is not implemented. args okay, where's that working with listing? Containers. Collections, is that what they're called? Working with collections in Pharo. I want to like enumerate them, right? I want something like enumerate. Enumerating collections. I don't need the number. Well, yeah, right, because I'm already getting the thing out. I was trying to get the numbers and like actually enumerate them, but I really just need to say arg. All right, so args. Not collect. Oh, just do is what we want. So args do. So for each arg, we're going to do s is going to be equal to s plus arg as string. But I bet we can even say join. And then we say args collect as string. Op as string. And then that. And then comma that. And then we don't even need this. We just say return this. Return op as string, comma that. And you know what? Let's even forget the infix string. Let's just comment this out for now, and then just return this and just see what this does. Op as string. Maybe we'll put the commas over here. Comma that. Comma that. Do it ML style. Or Elm style, I guess. I don't know. I don't think I need friends here. All right, let's try that. All right, so if that does what I think it does, then when I now inspect a new one of these things, I say print. Oh. Let's just say self as string. Yeah. Vex there and Right, so I would have expected that to show something. So when I click on this, Alt click on this, and I look at the source, I'm looking at the source for this view. Print string as wrote text. Okay. And then as string is okay. What does object as string look like? I see what overrides one method. Okay, I don't want to. Yeah, self print string. So really, I want print string. I really want to term print string. All right. So if I save that, then when I do this, and I say print, yeah, we do that. All right. So that means we need to inspect this thing, and we'll do the same thing. We'll add a class. We're going to add a class variable or class method, and it's going to be called. No, it's not a class method. It's an instance method. And it's the same thing, print string. And then this one is going to look like x plus, or not plus, but x comma vid as string. Okay, so if I don't think we can. Oh yeah, actually, I think it should do that, right? X bar. If I print it now and I refresh this, yeah, x0. That does not seem right. Why is the x0 coming up? Okay, so something's wrong with that function. Oh, I see. It didn't delete that. It just let's delete this print string. Okay, so let's just see what happens if we say join. I might have the arguments backwards. A, B, C. That's what I expected. Oh, it's I did need the parentheses here because this is. I think that's what's happening. Yeah, that was it. Because otherwise, it was taking that whole first string and there's no precedence. It's or the right. Yeah, it took everything that was up to that point and then used that as the joining mechanism. All right, so that's what I want to see. So and all right, so now that's a very rough visualization as a text string, and now we want to draw it, right? All right, so we need a Well, I mean, what's happened is I've constructed objects in memory now, right? And but I didn't use the idea of having a list of these objects that we're building as we go along, and that they have numbers, right? That's okay. Like as we create them, we can add them to a list, right? But what list? See, because oftentimes you're dealing with two different expressions. You know what? I'm not going to worry about this right now. I have a modeling problem where I have to deal with this because basically I want, you know, we have to do something, especially when we start talking about BDDs, we need to have like make sure all of these instances are unique. And so the nodes that we get back from these Bex constructor things, you know, Bex is basically you know this thing right here. Bex is a class that is acting as a factory for. Well, like I said, they really should be called Bex defs. So there should be a Bex def, Bex var, Bex const, and so on. Or actually Bex 0, or Bex O, Bex I. Okay, that's fine though. Let's ignore that for now, and let's just draw the graph. But how do we draw the graph? Like if I have a list, right? So here's an empty list. So let's say x's is equal to an empty list, and x's append. Is there an extend? No. What if you append what happens if you append like another list? And you inspect it. Does not understand what? Instance of array did not understand append. Okay, so instead we'll make an ordered collection. X's let's just browse the ordered collection. Add all. Okay, so ordered collection new x's add all. And what if we do this? ABC. Okay. So let's add all x's add AST, right? And then x's add all see, what I need is a flat list of nodes and the links between them. And it may be the case that I'm going to see multiple, like the variables might appear multiple times. Do I care about that? Maybe I don't care about that for now. Right, add all. Yeah, what I want to say is like, right, all right, finish the thought. I want to make like a walker here, like a thing that, you know, it's recursive, but it's going to have to be recursive on several different classes. So let's open a coder. And we'll go to Bex. Okay. I don't know what this does yet. I think it's like making a. I think these you can like declare interfaces of something, but like, what do you? All right. So anyway, I want. We got print string. We've got vid, and they all need to have a stencil. Like this has a stencil. Xvar needs a stencil. Canvas needs a stencil. But also I need to flatten them, right? So I need to, first of all, let's make a new class. And the superclass is Bex, and the name is going to be BexDef. Actually, it can just be a subclass of object. Right. And then the slots are going to be what I had before, so op and args. Right. I'm actually going to call it, I'm going to make it a subclass, and then I'll be, hopefully I can push methods down in the refactoring browser. Oh, it didn't like that. Slots appeared twice. Okay, so these, because I subclassed that, it already has these slots. So let's get rid of it. Okay. I don't think that worked at all. It did not. So let's try that again. Name, BexDef, slots, yeah. What's going on here? Close this, do it again. Something screwed up there. no, Beckstuff does not exist yet, so let's try this again. Beckstuff, name's already taken. Okay, so I did create a Beckstuff. Oh, I see it now. Okay, it's there. All right, so now let's go to this, and for the instance method, we're going to right-click, push down method. Bex is not an abstract class. Is abstract on the class, right? Is abstract. It doesn't say it's overriding that, so that, and it didn't. Open an abstract. How does it know it's abstract? It's abstract, yeah. In kernel behavior. It's on the instance? No. Testing class. Okay, so what did I do wrong? Is abstract. It's on the class. Superclass is object. Abstract font is a class. Superclass is object. Oh wait, it doesn't. Oh, it doesn't show that little thing if it's open. Okay, so it did do that. Okay, so actually we want to say self equals. What did I just say? I thought I saw two double. So what is it? What is that? Same object, same pointer. Okay, so Bex is a. I am a factory for creating binary or Boolean expressions. All right, so methods. All right, so I told it it's abstract, so now I think I can push this down to the subclass. So let's say push down method. X is not an abstract class. Pharo refactoring browser is not an abstract class. Yeah, this is a lot of work to just copy the dang thing. I could just Okay. All right. It is abstract. It says it's abstract there. All right. So print string. I want to push this down. Push down method. X is not an abstract class. It sure looks abstract to me. It's in italics. All right, whatever. Remove it. Yep. And we're going to add it back here. Boom. Somewhere there's probably a way to, you should be able to see all the superclass stuff. Nice. All right. Anyway, so here we're going to say this, but this time we're going to say Bex def. And then actually it's perfectly fine to bounce it back to that one. Okay. I think that's fine now. Okay, so the point of that was what? Just to break this into two classes. That was a small refactoring I wanted to do before I did the next set. So op args. So these are all constructors now. Okay. And now I'm going to save my work. I haven't saved it in quite a while, so I'm going to save it. You don't need this. Let's get rid of this and this. Actually, I was probably about to need that. Don't need this. Both for Bex. Don't need this. Oh. Keep the docs handy. Still works? Nope. Does not understand something. Self new Bex class new does not understand this. So yeah, this does need to be Bex def new. So we can say that and then resume. Right, so this created a Bex def and has two arguments, one of which is a var and one of them is a Bex def, and that has two arguments, and they're both a Bex var and a Bex var. Okay. And when we print it, it does say, and this is everything we want to say. So that's good. All right, and so now we have these three classes. I do want to open this up, Bex in a coder. And now I want to say a Bex def nodes. Right, and this should return, no, just nodes. A flat return, build a flat list of all subnodes. Or maybe I should call this descendants. And I always forget if the word is that way or yeah, descendants. Oh, that's a band, so is it? Ah, come on. Descendant is moving downward. Descendant is people. So descendants. A flat return a flat list of all subnodes. So return a list containing myself and all subnodes. We could do it in like RPN style, maybe, but I don't think we need, it doesn't really matter. Okay, so yeah, so we should say res is going to be res is self. Nope. Because you can't, I don't believe you can append things to a dynamic array like that. And then res add all. It's really more like args do arg. So for each arg, and we're going to say res add all each descendants. And I think also we don't need this. We say order collection new, and then we say add self oh right, so we do need that because it wouldn't just be an expression by itself. Okay, so args do each res add all. I always say as nodes, each as nodes. And then I guess really this could be we could make this a subclass of Bex, right? Whoop. I didn't mean to double click something. We could make this the const can be a subclass of. I didn't even double click it, just single clicking it. I want to change this. If I open this, now we can change it. X. All right, so now we have these. I think maybe even push these up. But we're going to do the same thing here. So Bex Vera is going to be a type. A variable is a type of binary expression. Bex. Okay. So const, defs, and vars. So const exists because I and O well, okay, so because these are both constants, and so they're singletons. These two are singletons. So we do need const here. And Beck's const should be abstract. So is abstract. That is a class method. And then, so the same thing, return self is double equal to Beck's const. Okay. Yeah, so now it's italics here, or in italics here. And so now I think so the stencil, the size, the drawing for, the geometry, the color, and the border. I think all of these can be moved up to Bex. And I can say right click here and say push, and then I'll get drawing for all these things. And so push up method. And now that should be in Bex, the border. All right, so push up the color. And in fact, I would like a different color for this. Color from hex string. No, you know, that's fine. It's like this is to me an ugly color, and the point is that when it shows up in a diagram, it means I need to see something. So, where's push method up? Again. Oh, I see. So depending on where you click, you get different things. So push up method. Boom. Geometry, yep. Push up method, yeah. Oh. Okay, that seems to have failed somehow. But I don't know, it worked. Didn't fail. I pushed, okay. Okay, so is abstract. Def. So now if I make a Bex def, I should see a drawing for it. It should just be a circle that's cyan, right? In the drawing tab, yeah, it should be, are not indexable. Open debugger. Okay. Answer the number of indexable variables in the receiver. All right, so I'm inheriting something that so I lost size. Is that my problem? Xdef. I don't know why this says what it says. Because yeah, maybe this was the bug that happened. I don't need this. Maybe the refactoring browser installed this for me. I don't really know. And I moved it. I think yeah, because I moved it up and I added it to Bex, and then so all the subclasses of Bex got a new variable called size, because it so as not to affect them. That's interesting. So that it like copied the Bex's superclasses implementation of size. So it's not. I bet that's what happened. That's my guess anyway. All right. Anyway, so I didn't want that to happen. Didn't expect that to happen. Didn't need it to happen. So now, and maybe that maybe we want to call that like Mondrian size or something like that, drawing size or something like that, icon size. But so now let's inspect this and we get a drawing. Yeah, and that's what I expected to see. Okay. So I really need two drawings. One is show me this thing as a node, draw it as a node, and then draw the graph. And only a Bex def would have a graph. Like the node, the other nodes would not have a graph because they're not compound objects, right? So yeah, like a constant would just be a circle. So we need two of these things. So or rather, instead of just drawing, like maybe we should call that a stencil, right? Like one would be the stencil, and then one is the or whatever, we'll call it the drawing, and then drawing is fine. Stencil implies that you're like using it as like a copy, I think. You're using many copies of it. All right, but this one needs, this class needs a way to draw not just itself, but all of its subclasses. Just like it's doing this and it's collecting all its children, it needs to draw something. It needs to draw all of its parents. So where we go? It would be really nice if I could see the superclasses, inherited stuff. Copy class, go to repository, show package and class hierarchy. Do some changes. PT drawing for. Oh, okay, whatever. We'll copy this. And then we'll go back to def and add a new one that is a paste. Oops. PT drawing for graph. This is going to be a Mondrian. It's basically the same thing as what the canvas did, right? And so we say painting, and then this takes the Mondrian, right? So it takes the M, or the G or whatever. So we say M nodes with, and then self as nodes. Does that look right? I don't know, because we need that working with Mondrian. So Mondrian, by example. View nodes with, and then what are the nodes? Yeah, okay, so if we do that, that should work. Did not understand collect. Where's my, let's just look at what I did last night, because I don't. View Mondrian priority painting. Oh, it's painting. Is that what I called it? Oops. I hit the wrong thing. I don't know how to move it back to that window. Backstaff. Oh, I also lost my. Okay. So this does not understand. Basically, this is just a. Let's take this X node shape with NIDs. Okay, so shape is what. This is what I want. With, but instead of, yeah, full block closure is trying to say collect, but you don't want, you don't. I understand that now. This can go away. I'm a little, I know this UI is a little confusing, but because I've opened up way too many things, I'm a little confused. I'm a little overwhelmed. Okay, that. I was also confused because, okay, Mondrian. Mondrian by example. That's what I want. And I also wanted it to change the name of this title, or at least sync up with over here. But it does not. Well, that worked. All right, Mondrian by example, and variables for Bex. And so my problem is GT graph for nodes with, and this should be in parentheses, self as nodes. So we say stencil is stencil, and then with, and then M layout tree, maybe just tree. As nodes. Instance of Pharo did not understand as nodes. Right, okay. So that we can go into the debugger, as it doesn't understand that. And then a Bex bar meta here. But actually we want to go all the way up now to Bex and implement as nodes. As nodes. And we're just going to return ordered collection new add self. And let's try that again. Did not understand do. Okay, so I tried to do it as one expression. It didn't like that. So I need to go to a Bex var, and I need to change that definition. No, again, it was all the way up here at Bex. And then as nodes, so again, res is equal to order collection new, res add self, and then return res. And then we're all good. And I'm curious if we can go back in the stack, just like in the debugger here. We just went all the way back down here, and we resume from this point. No, because this is a stack trace that's already been captured. It doesn't have a debugger in it. It's just a stack trace. right, so we can just regenerate. There we go. And then these are all looking weird, but if I double click on any one of them, it says this one is a var. When I look at the print, it's x2. This one is an XOR. This one is x1. This one is x0, and this one is an AND. Okay. So one thing I want to do is up here in the stencil, I want to put some text on it. So BL element, let's browse BL element. Maybe let's open it up here. I don't think an element can just have text on it. I think like you need a text element to add to it. Maybe add child. So then we would add like a BL text. But no. Block text. You know what? I have something that already does this. So it does exactly what I want. So if I search for well, I don't know, but I go here and my examples, and I have a not a Bex canvas, but this one. Graph. Graph builder is what I want. Right, so if I look at the graph, no. Look at the result. Example, what? Okay, so the BDD graph. And now if I alt click on this and see what it did, oh, so you can just say text. Text at as rope text. Okay. V. Yeah, so this was like a list or something. Oh no, it's a dictionary that has, yeah, each one of these is just a dictionary has a key called V for. Okay. So text is just something that Mondrian does. So in that case, in the stencil, say BL element, and we just say text self. We don't want as string. We just want like node text. Message is not implemented. Oh. Where did I see that though? I saw that in the Vuebex graph builder. I clicked on here. What has text? BL text element new. And it has geometry, and it has, okay, so I just have to change it from element to text element in the stencil. GL text element new. It still has geometry, it still has the background, it still has the border, but now it has text. And then now we have to add this self node text. And it's just going to return an empty string. Okay. All right, so now, if I look at this, I think I have to remake it. The text must be an instance of text. Oh, okay, so it did try to remake it, but it's failing. And so node text. So we'll say self node string as rope text. And then that's it. And then we're going to add a, now this will return the, that way. And that way, if I just have a simple thing, I can just override this, and then later I can make something more complicated. Okay, so now try that again, and now I think we just have to rebuild this now. Drawing, graph. Right, okay. Now if I double click on this one and we go to a Bex def, and we're going to add a node string, right? And then we're going to return self, and we're going to say op as string. All right. We have to rebuild again. Yes. Ooh. Okay. Well, that's not quite what I expected. So we see and or, XOR. So we'll try these paddings. Mondrian by example. Oh no, I think I don't need this anymore. Don't need this. And then we'll change this to add this line padding. Okay. Then come back over here and run it again. Whoa! What the heck is happening? Okay, well, that's not what I want, but don't really know what to make of that yet, but okay. With VHLs, edge, layout tree. Let me just copy this and see what maybe I'm missing something here. Bex canvas, Bex is here. I'm going to paste that in here just so I can, for reference. This is code from my old visualization. I think that's what it is. I need the shape to be a message that I send to the X, and then the X is going to give me its own thing. So this is like saying X stencil, right? And so this is just shorthand for this, I believe. Let's try that. Oh, but I think we have to rebuild it. Oh. Mm-hmm. Let's see what AST as nodes is. AST as nodes. And we're gonna graph it. So it's just those 5 things. That's right. Exactly what I expected it to be. Padding border geometry, and here I'm doing padding border geometry text and size. What if I took the size out? Because it is a problem with size. Okay, that worked. So let's add a to-do. We don't want to make a text node, right? Text node. To fix the sizes. I guess each little line of text is each little paragraph of text is its own cell. So then you could say, move this over. Whatever. Okay, that's fine. And then now we want to draw a line. We want to draw edges. Right, so Beck's canvas, and then not this one. This is I want the old one. maybe I should move this over. So make this bigger. Yeah. So edges connect to. The edges connect to. Oh, for each edges, for all the edges. We're getting the list of edges, and it's like, so for each n, basically connect edge value n to edge value low. I need to call many of these. Edge. Edge is a node. Oh, I see. So this is a closure with two arguments. So for n, which ref? Yeah, I think I need something else here. I bet you can have like a list. We'll find out. Let's look at Mondrian by example again. How do we connect the edges? Connect. Make this super big? Nope. Doesn't seem to be letting me move these ones. Edges between nodes, okay? Self edges between nodes. Connect. Few edges connect. Okay, so nodes with, and then it's just a list. Oh, I see. So you say connect, and then the list of things, and then you give it a closure, from and to. Okay, so I understand that now. Okay, so now I can just say you're here, self as nodes, and then we say m in the right place, right? Bex def, yeah. I want a definition to be m edges connect. So let's say nodes, nodes equals self as nodes. I want connect browse implementers. Mondrian Edge Builder. From a block to a block. From to all. That's what I'm looking for. That's what I was looking for. So connect from to all. And then okay. So all right. Do I need this? This is my old thing. Probably don't need it. I'll just keep it around. This is the canvas. I don't need this right now. This is the stencil for one node. This is the example. Okay, so I need to look at where am I actually looking? I need to look at the Beck's def GT graph for. That's what I want. Oh, where did it go? Here. Okay. I was already looking at this. It was just I lost my context. Okay. I just connect nodes from to all from, I think you can say yourself to all direct edges. Direct, just outgoing, to all outgoing, or just direct neighbors, direct children, right? Immediate children. And I believe I'll get a message that says immediate children is not understood. Did not understand immediate children. All right, so then open the debugger. Oh, but I just get a stack trace. So I can just go to Beck's def and I say meta. And then I just add a immediate children. And then this we will return self. We just return args. Okay. And then in the superclass, for everything else that isn't a def, or we have a compound thing, we will say immediate children, and then we will return an empty list. And so then I think that works. Yeah. And XOR. Okay, so now we need to show the graph. So the var All right, so variables and these things need to show their node string, and this needs to return I. Hopefully that's overriding, yeah. This needs to return O. And then the print string, we will rename this to node string. And then the print string we can just delete because that's already, I believe print string is already oh. It was the other way around. No, that's op as string. So this is specific. So node string is this, but there's no as string. So I think we should say self as string, and then yeah, when we do the stencil, then that should show node text, which is node string as rope text. So I like that. I'm not sure. We'll see. I might need to change it around a bit. Anyway, but that allows me to override the. All right, so that's it. That's my very ugly looking thing. Okay. Okay. Like I want all the sizes to be the same, or roughly the same. But I like that. And I click on any one of these things, I get the actual node I'm looking at. Far, far, far from perfect, but I think I've been doing this long enough. Yeah, it's already 2.5 hours long. So I think I'm going to wrap this up. And this will just be a good stopping point. So let me save this. Git. So ts Pharo. This is a much coarser grain commit that I normally like to make, but whatever. So implement drawings for, so say Bex drawings for say classes and drawings for simple for compound expressions for vars, consts, and defs. depths. Compound expressions and depths expressions. Classes and drawings for simple AST expressions. How about for simple expression? For simple syntax trees. For abstract syntax trees. Okay. So I don't need this anymore. And I think I'll leave that right where I left off. So viewbacks don't really need this on screen anymore. All right, well, I found that a lot of fun. I'm having a lot of fun learning Smalltalk here and playing around with this. So let's take a little screenshot for Twitter or something, and fix the sizes and colors. Fix the colors. To-do list. Sizes, fix the colors. Draw some arrows, maybe. Arrows maybe. All right, and that'll be my screenshot. All right, so thanks for watching, and I'll hopefully see you again soon. And stream.